Look around you. The world we live in is a mesmerizing tapestry of life. Where the galloping of horses paints the landscape with a myriad of rhythms. From the towering majesty of ancient forests to the mysterious depths of our oceans. From the resilient spirit of diverse communities to the untamed beauty of the animal kingdom, our planet is a masterpiece beyond compare. But amid this extraordinary beauty, have you ever paused to wonder how it all began? How this enchanting spectacle of life came to be? Imagine a moment of utter awe at the universe. There was no such thing as the universe 13.8 billion years ago. In its place, a tiny roiling stew of energy that had been crushed into a singularity was all that was present. The universe then erupted in a spectacle of creation, with an eruption of unfathomable force. This was the Big Bang, the violent conception of everything that exists today. It launched the cosmos into existence by marking the beginning of space, time, matter, and energy. Now, here's where it gets truly mind-bending. In the blink of an eye, a mere fraction of a second, the universe underwent a cosmic growth spurt, inflating exponentially, expanding at an astonishing pace, far exceeding the speed of light. The temperature of the entire universe was 1,000 trillion degrees Celsius at just a tiny fraction of a second after the explosion. Even the cores of the hottest stars in today's universe are much cooler than that. An essential quality of the Big Bang sets it apart from all other explosions. You see, when we think of explosions, we imagine them expanding through a medium like air or water. However, the Big Bang redefines our understanding in a breathtaking way. It didn't merely expand within pre-existing space, because at the dawn of time, there was no space to expand through. Instead, it performed an extraordinary cosmic feat. It conjured space itself into existence and then stretched it out. This concept is so profoundly astonishing that it leaves us in awe of the universe's boundless creativity. In this extreme hotness of the universe, just a mere fraction of a second after the Big Bang, something remarkable happened. Protons and neutrons, these tiny yet essential particles, emerged into existence. They swiftly teamed up, despite the searing conditions, to form the earliest building blocks of matter. These were primarily hydrogen and helium, like the first strokes of a cosmic artist's brush on the canvas of creation. But the story didn't end there. Over the course of hundreds of thousands of years, as the universe cooled down, another type of particle called electrons began to delicately adhere to these building blocks, completing the puzzle and giving birth to the very first atoms. This transition dramatically altered the cosmos. It was like lifting the fog that had shrouded the universe since its birth. Photons, which were previously trapped in a cosmic pinball game, were suddenly set free. But throughout their protracted imprisonment, these just-released photons underwent changes. They had become longer and cooler due to the universe's expansion, thereby turning into microwave radiation. The cosmic microwave background is the term used to describe this stretched, cooled radiation. Over time, the relentless pull of gravity took hold, causing matter to gradually clump together in regions of slightly higher density. These density fluctuations served as the cosmic seeds from which galaxies would eventually grow. These galaxies, composed of vast collections of stars, gas, and dust, held within them the potential for new stellar life. The birth of stars is a story of gravitational mastery and the interplay of cosmic forces. Deep within the cold, dark, and dense regions of galaxies, gravity seized control, compressing pockets of gas and dust. As these regions grew denser, their gravitational pull intensified, causing them to collapse under their own weight. This collapse initiated a process known as nuclear fusion, a cosmic alchemy where hydrogen atoms fuse together to form helium, releasing an incredible amount of energy in the process. This energy, in the form of light and heat, illuminated the dark cosmic corners and brought new stars into existence. These newborn stars, often surrounded by the remnants of their birth, shone brilliantly, becoming the celestial beacons of their galaxies. Over time, they evolved, some becoming massive, short-lived giants, while others matured into stable, long-lived stars like our Sun. Stars, the cosmic engines of light and life, played a vital role in shaping the destiny of their galaxies, enriching them with heavy elements and, in some cases, birthing planetary systems where the seeds of life could take root. After the birth of the massive stars, some of them at least 8 times the mass of our Sun, ended in a cataclysmic event known as a supernova when they eventually exhausted their nuclear fuel hundreds of millions of years after the Big Bang. When these stars exhausted their nuclear fuel, their cores collapsed under gravity's immense pressure. The core implosion rebounded off the dense outer layers, creating a shock wave that teared the star apart in a titanic explosion. During this explosion, temperatures and pressures skyrocketed, enabling the creation of even heavier elements through rapid nucleosynthesis. These explosions released an astonishing amount of energy and scattered heavier elements into space, often outshining entire galaxies for a brief period. The remnants of supernovae and other cosmic processes led to the formation of planetary systems. Within a portion of the Milky Way, a massive molecular cloud made of gas and dust started to collapse around 4.6 billion years ago due to gravity. Our solar system was born inside of this cloud. It started spinning as it fell, creating a rotating disk of substance. In the center of this rotating disk, the majority of the material concentrated and formed our young Sun. Meanwhile, in the surrounding disk, the remaining matter began to coalesce into smaller objects called planetesimals, which were the building blocks of planets, including Earth. In the region between the orbits of Mars and Jupiter, known as the asteroid belt, many of these planetesimals remained. These asteroids are remnants from the early solar system, containing a wide variety of materials, including metals, silicates, and other compounds. Over billions of years, asteroids in the solar system collided with one another. While some of these encounters were violent and split bigger asteroids into tiny fragments, others were milder and allowed for the interchange of minerals. Within the protoplanetary disk, planetesimals collided and merged over millions of years. These collisions released energy and caused the planetesimals to heat up. As these protoplanets continued to collide and grow, one of them in particular became dominant in size and mass. This protoplanet eventually became Earth. Its gravitational influence allowed it to gather more and more planetesimals and smaller protoplanets. Around 4.5 billion years ago, after Earth had already taken shape, a dramatic cosmic event occurred. A Mars-sized object, sometimes referred to as Theia, collided with the young Earth. This colossal impact was so powerful that it forever changed the course of Earth's history. It was a catastrophic occurrence when Earth and Theia collided. Theia and some of Earth's outer layers were vaporized as a result of the collision's immense energy output. It produced a tremendous quantity of heat as well as a huge cloud of debris. From the debris cloud created by the impact, a large portion of material began to coalesce and form what would become our moon. The moon, initially molten and in a state of upheaval, was in orbit around the early Earth. Immediately following the moon-forming giant impact, the young Earth was in a state of extreme heat and turmoil. The surface was predominantly molten, making it an inhospitable place for any form of life. However, as Earth slowly cooled over the course of millions of years, a significant transformation occurred. Water vapor present in the early atmosphere began to condense into liquid form, giving rise to the formation of Earth's first oceans. These oceans, still very different from the ones we know today, represented vast bodies of water that covered substantial portions of the planet's surface. Everywhere you looked, there were expanses of deep blue ocean stretching to the distant horizon. The ocean's depths were profound and mysterious, plunging to depths far greater than any modern ocean. The sunlight barely penetrated these inky depths, where darkness and secrecy held sway. Earth was a solitary celestial body in the cosmos, surrounded by the profound silence and emptiness of space. The stars above, unobstructed by city lights or pollution, would have shone brilliantly in the night sky. In the absence of complex life forms, the world was characterized by a primordial calm. There were no sounds of animals or rustling leaves, just the gentle lapping of waves against the shore. Life on Earth evolved over billions of years through a gradual process. It all started with tiny molecules forming in the oceans. Some of these molecules could make copies of themselves. These self-copying molecules, like the first builders, made more complex structures called protocells. Protocells could do simple tasks and survive in the ancient ocean. Over time, some protocells improved at surviving and making copies of themselves. These improved protocells eventually turned into the first simple life forms. For billions of years, simple single-celled life forms controlled the planet. These tiny creatures, like bacteria, were the first living things to appear on Earth. Some single-celled organisms eventually joined forces to create multicellular living forms. The structural complexity of these early multicellular organisms was still fairly low. Life diversified into various forms, adapting to different environments. Oceans teemed with marine life, and some life forms ventured onto land, eventually evolving into plants and animals. Invertebrates, such as insects and mollusks, emerged. Fish were among the first vertebrates and developed fins for swimming. Some organisms from the ocean started migrating onto land as life continued to develop. They were amphibians, the first terrestrial creatures. Amphibians were unique in that they could live both on land and in water. They were the first animals to transfer to land that were vertebrates, which means they had a backbone. They evolved limbs and lungs, enabling them to breathe air as a means of acclimating to this new environment. This transition to land was a crucial stage in the evolution of life because it introduced terrestrial ecosystems and opened the door for later, more advanced life forms. The dinosaur era, known as the Mesozoic era, spanned approximately 180 million years, starting around 252 million years ago and ending roughly 66 million years ago. Dinosaurs, including well-known colossals like the Tyrannosaurus rex and the long-necked Brachiosaurus, dominated the Earth throughout this period and underwent considerable diversity. But a disastrous tragedy that took place some 66 million years ago was highlighted by a massive asteroid impact in what is now the Yucatan Peninsula, Mexico. Large-scale wildfires, a nuclear winter scenario caused by debris blocking sunlight, and disastrous environmental changes were all brought on by this event. The end of the Mesozoic era and the beginning of the Cenozoic era, when mammals finally became well-known and modern ecosystems began to develop, were marked by the mass extinction of most dinosaur species. Small insect-eating mammals and creatures resembling modern rodents populated the planet. These early mammals displayed a wide range of sizes, diets, and behaviors. Approximately 200,000 years ago, modern humans emerged. Some of them adapted to life in trees and began using simple tools. These early bipedal creatures formed communities, fostering cooperation, resource sharing, and protection within their groups. A significant turning point came when some communities shifted from hunting and gathering to agriculture. They learned to cultivate crops and domesticate animals. Over time, agricultural communities evolved into the world's first civilizations. These societies featured organized governance, complex cultures, and technological innovations. Interactions among these early civilizations sparked scientific, artistic, and cultural progress, shaping the foundations of our modern world. As we conclude this awe-inspiring journey through time, we've uncovered the incredible story of how life, against all odds, began on Earth. From the fiery birth of the universe to the emergence of complex, thinking beings, our planet's history is a testament to the grandeur of nature's creations. From the spark of the first single-celled life forms to the towering majesty of the ancient forests and the galloping of horses across grassy plains to the symphony of colors, shapes, and stories that is humanity, our planet's history has been a tale of resilience, adaptation, and progress. As we continue our journey of discovery and exploration, let's remember that the wonders of the universe and the mysteries of our own existence are still unfolding before us. It's a reminder of the boundless potential of life on Earth and our responsibility to cherish and protect this remarkable home we all share. Thank you for joining us on this incredible voyage through time and space. If you've enjoyed this journey, don't forget to like, subscribe, and share. Stay curious, keep exploring, and together we'll uncover even more of the universe's fascinating secrets. Until next time, stay inspired.